Okay, so in this video, I'm going to demonstrate how to create a set of orthogonal fractional contrast codes. So this is the second video in this series. I kind of introduced why we're talking about this in the first video. So if you haven't watched that, I recommend going back and watching it. I'll include a link to that video in the description. But so in this scenario, or this video, I'm going to be demonstrating how to do this, creating a fractional, orthogonal fractional contrast codes. So I have a couple things written down here, and this is kind of the process that we're going to go through each time, but this might not make a whole lot of sense, so I'm going to be demonstrating it over here on the right. So just to introduce you to this though, um, when we create these orthogonal contrast codes, we need to determine how many we need to arrive at a full set of orthogonal contrast codes. And it's very easy to determine that. So you just take how many groups you have. So in our example, we have 4 groups, 1, 2, 3, 4. So you just take the number of groups and you minus 1. So in our case, that would be 3. So we know we're going to need 3 contrast codes to create a full set of contrast codes. So that's step 1. So the next step, or the next thing to talk about, is the criteria for orthogonality. So what we mean by the codes being orthogonal is we want to create codes that aren't correlated with each other. So anytime you're running a regression, you want to watch out for multicollinearity. So you don't want your predictors to be related to each other. So because we're creating these codes, and these are going to end up being our predictors in our regression model, we can make sure that our codes are not related to each other. So we're going to make them orthogonal. So there are some criteria that we can use to ensure that the codes that we end up creating are orthogonal. So there are 2 criteria. The first one is the weights that we use for each code must sum to 1, or sum to 0, sorry. And then the cross products for each pair of codes must also sum to 0. So that might not make a whole lot of sense, but I'm going to demonstrate this in a second. And then after we've created our orthogonal set of contrast codes, I will show you how to make them fractional. So it's very convenient to make your contrast codes fractional because the regression coefficient that comes back in the output will represent a 1 unit jump, or the mean difference between the groups, rather than like a third of the mean difference or like half of the mean difference. So it's a bit convenient to make them fractional, and I recommend making your contrast codes fractional. Okay, so this is scenario 1. So I'm actually going to demonstrate 2 different scenarios. In the next video, I'll do scenario 2. And these scenarios are only differentiated by the primary hypothesis that's being tested. So like I said in the first video, using orthogonal contrast codes are nice because they allow you to test your specific research question immediately. So rather than, again, trying to run this 2-step ANOVA process where you check to see if the omnibus test is significant and then you go in and do these post hoc tests, this will allow us to test our research question right away. So in this scenario, our primary hypothesis is that group 4 will have significantly higher scores on the dependent variable compared to the other 3 groups. Okay, so that's our primary research question. So we want to make sure one of our codes tests this research question. So I like to test the primary research question with the first code that I create. So I'm going to put this right here. So this is where we're going to name our codes. So I'm going to say group 4 v other. And how I typically like to name these codes is I like to put the group that I'm expecting to be highest on the left, and then the group or groups that I'm expecting to be lower on the right. So that's just a convenience thing that I do. So in this code, we're going to want to compare group 4 to the other 3 groups. So there are a number of different ways you could do this, but we want to make sure that we're keeping the first criteria for orthogonality in our minds. So the weights that we use, what we're going to be doing here is generating weights for these groups. So they must sum to 0. So if I tried to say, okay, I'm going to make this group 2 and then these groups 1, that's fine. Now they're kind of differentiated. So this is a 1, this is a 2, and then these groups are 1, so they're kind of separated. But if you sum these up, so I'm going to create a sum column here. And this is, I like doing this in uh, spreadsheet software because it makes the math a lot easier. So all of these weights must sum to 1, or sum to 0. I keep saying 1. They must sum to 0. So I'll just create this and I'll check. So I'm just adding all of these up. And what you'll see is that this sums to 5. So this does not meet the first criteria of orthogonality. See, these codes will not work. Okay, so I mean, you could just make some minor changes. If we made this a 3, that's not doing anything. Okay, if you made these 2, right, that's not doing anything. It's summing to 9. It's actually getting worse. So what you'll notice to make these sum to 0 is one of your groups is going to have to be above 0, and the other groups are going to have to be below 0. Okay, and that's the only way you're going to eventually get them to sum to 0. So the way to do this is, again, I like to make sure my codes are kind of consistent with the hypotheses. So I'm going to make sure that the group 4 has the positive number and that the other 3 groups have the negative numbers, because I'm expecting them to be lower on the DV. Okay, so what you can do is you look at your group 4, you know this is going to be the group that's positive and it's going to be different from the others. So what you do is you say, okay, for group 4, you count how many other groups there are. So 1, 2, 3. So actually I'm going to leave this 3 here. So then you say, okay, how can I then make this sum to 0? You make these all negative 1. Okay, negative 1, negative 1. So now you see that these weights now sum to 0. So now this code right here meets the first criteria of orthogonality. All the weights of a code must sum to 0. Okay, so that just gives us our first code. So we know that's fine, but to create a full set of contrast codes, we need 2 more. So remember, we've already determined that we need 3 codes to set up a full set of orthogonal contrast codes. So we have our first code, but now we need a second and a third code to just fill out the set, even though we're not actually concerned or interested in these codes per se. But we need a full set of orthogonal contrast codes. So the strategy here is actually just to, with the remaining codes, break up the groups that have been paired or grouped together in previous codes, and then zero out the groups that have already been isolated. Okay, so what do I mean by that? So group 4 has already been isolated in group 1, or the first code, right? It's not grouped with any other group. It's just by itself. So we're going to zero this out. And then here you see that for groups 1, 2, and 3, they've been clumped together in the first code. So in the subsequent codes, we want to make sure we can differentiate them. So ungroup them in a way. So what I can do here is just maybe, and again, this is where it gets flexible. You can do this in a lot of different ways, but I don't actually care about what's being tested in these 3 groups, because my primary research question, all I really care about is this one, which I've already specified in our first code. But I need to just break these up somehow. So I can actually just do something consistent with Helmert coding, which is just kind of follow the same process I did for group 4 compared to the other 3 groups, but just kind of narrow it in to just group 3 compared to the other 2. So if I'm going to isolate group 3, so there are going to be 2 other groups here. So I'm going to put a 2 here, and then a negative 1, and then a negative 1. So what you'll see if I bring this down, this also sums to 0. So this actually works. Okay, so now this code meets the first criteria of orthogonality. So I'll give this a name. I'm going to call it group 3 versus group 1, group 2. So notice I'm being very descriptive. I'm saying group 4 versus other, so that means all the other groups. My second code is group 3 versus, or compared to, group 1 and group 2. Okay, so we need a final group. So we've already isolated. So like I said, we zero out groups that have already been isolated. So group 4 was isolated in the first code, so we're going to zero it out again. Group 3 was isolated in the second code, so we can zero that out. So then we're just left with these two groups. So notice that these two groups at no point yet has group 1 and group 2 been detached from each other. So that's what we're going to do in this final code. So we'll just set group 1 or group 2 to 1 and group 1 to -1. Again, if we just double check this, bring it down, and yes, this code also sums to 0. So this meets the first criteria of orthogonality. So let's give this a name. We're going to call this group 2 versus group 1. Okay, so we're now at the point where we meet the first criteria for orthogonal contrast codes. So this is the part where people sometimes get confused. But the second criteria for orthogonality is that the cross product for each pair of codes must sum to 0. What does that mean? I'm just going to demonstrate this to you. So essentially, we need to pair each set of codes, multiply their weights together, and then the products of that must sum to 0. I'm missing my words here. But let's just demonstrate this. So I'm going to start with code 1 and code 2. So I'll just create a name for this. I'm going to be comparing code 1 and code 2. Next, I'll compare code 1 and code 3. And then finally, I'll compare code 2 and code 3. So each pair of codes. And what am I doing here? So for this cell, I'm going to multiply the weight, just all within group 1 here. I'm going to multiply the weight used in code 1 and the weight used in code 2. So I'm going to equals, select the weight for code 1, multiply by the weights for code 2, because this is multiplying 1 and 2. So you do that and then enter. Don't take that recommendation. So notice here, and if I double click, you can see that which cells are being used. So multiplying H1 by H4. And if I hit enter, it's 1. Why is it 1? Because -1 times -1 equals 1. So then what you can do nicely using this kind of spreadsheet software, so I'm using Google Sheets, just drag this over, and it applies the same function for each cell. So now this is multiplying 1 and 2 for group 2. This is multiplying 1 and 2 for group 3. This is multiplying code 1 and code 2 for group 4. Okay? So these are the cross products of code 1 and code 2. So what the second criteria for orthogonality says is that these cross products must sum to 0. So I can just bring this down again and see that it does sum to 0. If you add up all of these cross products, it sums to 0. And you could just kind of double check this, like a 1 plus a 1 is 2. This is -2, so that goes to 0. Then you end up with 0. So this sums to 0. So this is good. Okay, so the cross product for code 1 and code 2, the sum of those cross products is 0, so that's perfect. So now let's do this for comparing codes 1 and 3. So we do the same thing, equal. We select the weight for code 1 for group 1, and then the weight for code 3 for group 1. Multiply 3. Okay, so this will give us the product of the weights for group 1 for comparing the weights for code 1 and code 3. Okay, so this is 1. So -1 times -1 is 1. So similar to the first one. But now we drag. Okay, so this represents this times that. This represents this times that. This represents this times that. And then when we sum these, we again get 0. Okay, so this is working out great. So let's finish this off. So now the sum of the cross products comparing code 2 and code 3. So we do this again. This is the last time. So now we're comparing code 2 times code 3. Okay, And again, we end up with a positive 1, but then we drag this over, and this occurs for each group comparing code 2 and code 3. Okay? And what you can see is you can kind of guess that this is going to sum to 0. So if we drag this down, it sums to 0. So now this right here, if we focus in, this right here is a full set of orthogonal contrast codes. Okay, so they are not yet fractional though. So what I'm going to do is actually just kind of copy, hopefully this works, and paste just the values. Can I get that? Just the values. So we know that this is our set of contrast codes. I've just brought it down here. I don't want to mess with anything up here for now. So here's our full set of orthogonal contrast codes. The last step here is making them fractional. So this is the two-step process I would encourage you to go through, is ensure that your codes are orthogonal first, then make them fractional. So the rule for making codes fractional is you divide each weight within a specific code by the unit jump from the lowest to the highest weight. So what does that mean? So if we focus in on the first code, we see that we have a -1 is our low, and a 3 is our high. So how many unit jumps does it take to get from a -1 to a 3? The answer is 4, right? So -1 to 0, 1, 1 to 0 to 1, 2, 1 to 2, 3, 2 to 3, 4, right? So going from -1 to 3 is a 4-unit jump. So what you want to do then is divide each of these weights by 4, okay? So the way you can actually just do this directly, in the spreadsheet software. So if you go equals -1 divided by 4 equals -1 divided by 4 equals -1 divided by 4 equals 3, divided by 4. Okay, so now that is fractionally contrast coded. So let's just make sure that we are retaining our orthogonality criteria from before. So let's just sum all of these up. I'm kind of doing it the long way, but I'm just demonstrating here. These still sum to 0. Okay, so that's good. These need to retain all of the criteria for orthogonality, even though we make them fractional. Okay, so this one works. So now let's go down to the next one. So going from a -1 to a 2, that's a 3-unit jump. Okay, so we are going to divide each of these weights by 3. Okay, and then finally 2 divided by 3. And then we could also do this one. It's not going to change a whole lot. Okay, and then let's make sure this still sums. It does, still sums to 0. Okay, so then finally let's go down to our third code. So the unit jump from our lowest to our highest is -1 to 1. So -1's our low, 1 is our high. There's a 2-unit jump between those. So we're going to divide each of these codes by 2. And then we could do this for the 0 just for completeness, but these are just going to remain 0. Okay, and then we can make sure that that still sums to 0. So perfect. So let's just finish this out and make sure that the sum of the cross products for these still retains meets the criteria for orthogonality. Okay, so we're going to first compare codes 1 and 2. So we're going to do the same thing we just did. Oops, I think I messed up there. I was holding shift. Let me start over. Okay, so code 1, multiply, okay, by code 2. Okay, we drag it over. All right, I hope this works. Drag it down. Yes. Okay, so the cross products, the sum of these cross products is still 0. Perfect. So now let's check for comparing code 1 and code 3. So code 1, oops, what are you doing? Stop with these suggestions. Code 1 times code 3. Okay, drag it over. Make sure it still sums to 0. Yes, it still sums to 0. So now let's compare codes 2 and 3. So 2 times 3. Drag it over. Make sure it sums to 0. Okay, yes. So right here we have a full set. I'll just paste it down here, values only. Right here is a full set of orthogonal fractional contrast codes. Okay, so I'm going to demonstrate how to do this in the next video for testing a different research question. So remember, this first code right here is our primary research question. Okay, this is all we really care about in terms of our hypothesis. These other two codes were just created to make sure we have a full set of orthogonal contrast codes. Okay, so I'm going to demonstrate how to do this again with a different primary research hypothesis. Okay, so I'll see you in the next video.